BGP path. See, the protocol BGP is special because of the way that it elects path. BGP never focuses on bandwidth or delay or hop count as a metric to choose a path. It uses attributes. That makes this protocol special. Using the attributes, we define the policy. So when BGP elects a path based on attribute, the paths are selected based on a policy. This is what we need between autonomous systems. Between autonomous systems, we do not want to focus on bandwidth. Why? The interface bandwidth and the bandwidth we actually purchased, subscribed, will not be same. So if a routing protocol elects a path based on bandwidth, that won't be fine. Remember, in EIGRP you might have learned on the WAN interface, we need to set the bandwidth manually, matching the committed information rate on the frame relay interface where WAN is running. Again, if you don't understand what I'm saying, it's okay, forget about that. What I simply mean is, BGP do not want to focus on bandwidth or delay or anything on the WAN links, meaning between the autonomous systems, and it is good because the bandwidth on the link and the committed information rate will not be same. Then what do you want to focus when you're picking the path? If I have multiple ISPs, if I have multi-homing, then what should I focus if not bandwidth or a hop count? We want to focus on the policy. So BGP helps us to pick a path as per the policy. Policy-based routing. Based on the policy, the path is selected. So, policy-based routing. BGP is a path vector routing protocol. The path vector is determined based on the policy. Now, this attributes that helps us to apply the policy in path selection can be categorized into these 4 categories. Well-known versus optional, mandatory versus discretionary, transitive versus non-transitive, partial. We'll see what these are. The next slide. Well known means what? Popular. Well known means popular. This particular attribute, which is popular, known to every vendor that runs BGP, is what called as well-known attributes. For example, next hop for every route is a well-known attribute. When I receive an update from a neighbor for a network, for a destination, that update must have. The update must have next hop. If an update comes without next hop, that's of no use. Next hop is mandatory. Update must have next hop. So well-known attributes or the attributes that must be recognized by all compliant BGP implementation. Means every BGP device should know that attribute. If so, it is called as well-known attribute. So these attributes are definitely propagated to other neighbors. The reason why? Because it's a well-known attribute. Everyone knows it. Example, I told you, next hop. When you advertise, you need to advertise with next hop. Without next hop, no update is valid. We should know where to forward the packet, which next hop to forward the packet for the destination. Okay, in this well-known, there are two types again. Mandatory, discretionary. Well-known mandatory attributes must be present in all update messages. Example, next hop must be present. Well-known discretionary attributes may be present in update message. Example, MED. Multi-exit discriminator is also an attribute well known to everyone, but MED is an optional one. If you put MED, it is going to be based on MED, the path election. If not, some other attribute. Still, the update is valid. Even though the well-known attribute is not present, the update is still valid. Well-known mandatory, well-known discretionary. So now, in this we have seen what well-known is, mandatory is, discretionary is. Now optional. Well-known opposite is optional. They are recognized by some implementations, could be private, but expected not to be recognized by all BGP routers. Not everyone will have this. Recognized optional attributes are propagated to other neighbors based on their meaning. Optional transitive attributes means what? An optional non-transitive attribute means what? Optional transitive attributes, if not recognized, if that particular attribute is not there, the packet is still valid, but the only meaning it will give is partial. It's not completely trustworthy, but you can trust if there is no other option. That's the meaning, partial. You may use it if there is no other option. If not recognized, marked as partial and propagated to other neighbors. Optional non-transitive attributes. Discarded if not recognized. So, if a particular attribute is not there, the packet is going to be discarded. Even though it's an optional one, even though it is recognized by some implementation. If it is not there, it is going to be discarded. Such attributes are called as optional non-transitive attributes. If not there, I will not transit. I will not give. That's what non-transitive. So we have seen this. What is partial? If not recognized, if the optional attribute is not recognized, it is marked as partial. You have seen what is transitive and non-transitive, optional, mandatory, discretionary, well known. All of this. Now BGP attributes are many actually. We are going to see almost 13 attributes, in which here a few are shown because they are well known. MAD is well known, you see. We saw in the example when I was explaining you. Next hop is well known, but the difference is what? See, the next hop has got a star, and for the star there is an explanation at the bottom. Mandatory, must be there. But MED is also well known, not mandatory, may be present. Though it is well known, even if it is not present, it's okay, it is still valid update. This is not in a sequence, this attribute list that you see, AS path, next hop, origin, it's not in a sequence. That's why I don't want to speak much here. But I just want to give you here, there are 3 well-known mandatory attributes and 2 well-known discretionary attributes. May be present, may not be present, but well-known. Local preference is also a well-known attribute. Right, so before we go and see the sequence of attributes, the order in which the attribute is going to be checked against the path selection, we need to first understand this terminology, AS path, See, AS path is one of the well-known and mandatory. BGP is a path vector protocol because it will show the autonomous system path via which the destinations are reachable. AS path attribute means what? The autonomous systems via which the update has reached you. For example, router B. Router B learns about 192.168.0.1. This network is advertised from this autonomous system 64520, and there is no direct connection to B. So it comes to autonomous system 655500, and then from here only it is given to this. So when B learns, it learns like this: received from 6500, and that has received it from 64520. So it shows the autonomous system through which the update is given here. The first number will be the immediate autonomous system. The last will be the originator from where the network is advertised, from where the BGP got this network introduced. From where? From this autonomous system 64520. So the last autonomous system number in the AES path list is where from the network originated. The very first is the autonomous system from where this autonomous system received it. AES path attribute is a well-known mandatory. Next hop attribute. See, as I told you, next hop is well-known mandatory, but the next hop need not to be the next hop address which is seen on the immediate next router. The next hop router may be an address behind a router, or it may be the loopback interface IP address of the router. The next hop address will be always the address that is used to configure neighbor. Please understand this. Let us assume I'm going to talk something which is not on the screen. Let's assume I got a loopback interface here 1.1.2.2.2. A and B are forming neighbor. A and B are forming neighbor using the loopback. Someone tell me, answer me, what is the neighbor address of B? What is the neighbor address of B? According to B, what is the neighbor address? Answer me, please.
10.10.1.
I simply say it now. Loopback interface is used as the neighbor.
If you it's 2.2. If you use loopback.
AMD
1111.
1111. For B, A is neighbor. A is identified as 1111. A is identified as 1111. Now, according to B, when it learns this network, when it learns 172.16.0.0, it will learn with the next hop address, not this one, but this one. Understand this very well. Next hop address need not to be the directly connected physical address. It depends on what address we used in the neighbor statement. See, it's not explained here, but it should have been explained before coming to this story. They should have explained this, what I have explained. That's why I have added in the middle. See, the IP address of the next autonomous system to reach a given network is the next hop. The IP address of the next autonomous system to reach a given network is the next hop. A advertises this network to be in eBGP with next hop this. So A is advertising with this physical interface address. B is advertising the same network to its IBGP. Focus here, very important. When B advertises this network which it learned from A, when B advertises to C, it will not put its own address. It will put A's address. So when C receives it, it receives it with this as the next hop. B will not switch it to its own address. B will just carry the address given by A. B will simply carry the address given by A. So when C receives it, it will receive 172.16.0.0. Next hop, what? 10.10.10.3. Is 10.10.10.3 a real next hop for C? No. Then why it sends 10.10.10.3? Because it's the IP address of the next autonomous system to reach a given network. BGP is an autonomous system by autonomous system protocol. It is not internal hop by hop routing protocol. For BGP, the next hop will be the next autonomous system's address. If the next autonomous system is identified with this address in the neighbor statement, then it will be this. If it is identified with some loopback address, then here it will be 1.1.1.1, because in B your neighbor statement says neighbor is 1111. Understand this very well. This is the place where many don't have clarity. The next hop attribute is a well-known mandatory attribute. The next hop attribute is well-known mandatory attribute.
Hello.
Yes.
So I have a small question here.
Yes. Yes, please.
Between B and A, there will be a slide. It is showing EBGP, right? Whatever we mention as an extra neighbor defined in BGP configuration, that neighbor will
Be the next hop address.
So my question is logical IP, right? 111 loopback IP. So router B knows communicate without 10.10.10.3.
For that we will have a static route. Whenever you form neighbor using loopbacks, you need to have an IP path. For that you need to write a static route. Between these two routers you need to write a static route so that TCP three-way handshake will happen. This we learned in BGP fundamental. We also need to say what? Update source command. We also need to say what? EBGP multi-hop command. You forgot all this?
Yes.
Try to recall these things at least before the next class. Without those things, you cannot form neighbor using loopback to loopback. Yes.
Update source can be used only in okay, sorry, go ahead.
I mean, we can advertise loopback IP also, right?
Yeah, you can also advertise loopback IP in BGP, but to form BGP, you need an IP path. Without IP path, you cannot form BGP. Without forming BGP neighbor, how you will advertise the network? So first of all, to form neighbor, whether you are willing to advertise the loopback or not, in order to form neighbor, you need to have reachability to the loopback. Otherwise, TCP three-way handshake cannot happen. Yes or no?
Cannot form here.
Yes. So, mandatory, you need to provide an IP path either by writing static route or do something. There should be reachability to the loopback address with which you are forming neighbor. Origin attribute. Origin is an attribute so the origin attribute is an attribute that tells BGP how the network is introduced. BGP, like other protocol, they learn route in two different ways. One, the network command is used to advertise the network in BGP. The other way is how? Redistribution. Redistribution from other protocol into BGP. Two ways, no? In any routing protocol you take, whether it is OSPF or RIP or EIGRP or BGP, these are the two ways you can inject the network into the routing protocol. You can advertise using network command. The next method is you can take the route from some other source and redistribute it. It may be from a directly connected interface. You may redistribute the connected. It may be from a static route. You take the static route and redistribute it into BGP, or you may take a RIP route and redistribute into BGP, like with OSPF and EIGRP. These are the two ways in which you can introduce a network inside BGP, so that BGP will advertise it furthermore. But which one is more good? Redistribution or using network command? Network command is more good. Why? When you say network and advertise, it becomes BGP's own network. But when you redistribute, it is very clearly shown that it's not BGP's own, it is taken from some other source. That's what this origin attribute differentiates. Differentiates I and question mark. Smaller is preferred, I is preferred over question mark. Question mark is a redistributed route into BGP. I is an advertised route into BGP. I here means BGP's internal. This IGP is not a routing protocol IGP. This is not a routing protocol IGP. Routing protocol IGP like OSPF, EIGRP, RIP, ISIS. It is not that IGP. What it means is internal. Earlier days, BGP was not IBGP and EBGP. It was IGP and EGP. Now it is only one BGP which has got two flavors. So there is no more EGP protocol. It is totally gone, removed. So no need to worry about this. The origin attribute informs all the autonomous systems in the network how the prefix were introduced, whether it is introduced using the network command or whether the prefix is nothing but the network, how the network is introduced, whether it is introduced using the redistribute command or network command. To reach Yahoo, I am learning route from two sources. One with I, the other one with question mark. Which one I'll prefer? I'll prefer. Because I says that it is introduced using network command. That is preferred more than redistributed routes. The origin attribute is a well-known mandatory attribute. So this is also mandatory. You should see this. See, it informs to all autonomous systems. So definitely it is seen. It should be seen, otherwise it's not a valid update. Origin attribute is a well-known mandatory attribute. See here, when you type show IP BGP, you will see the origin code I, E, Kushman. I said E, you will never see. And this I is not this I. Not the I that is next to star. This I is the I that you see here. This I. If you find I, you can easily tell that this network is advertised in this autonomous system 64977, but now learned through different autonomous system 98 and 99, and it is introduced using network command here, not by redistribution. Only when you see question mark, you know that it is redistributed. Sorry. The next attribute is local preference. Local preference is an attribute that tells every router within the autonomous system about how to leave. If you want to go to a destination, how to leave the autonomous system. Among all these IBGP routers, if one router is having high local preference, that is the router via which the packet should leave. Let's read this. The path with the highest local preference are preferred. The default local preference is 100. The path with the higher local preference is preferred. If you have seen this picture, router A has got local preference of 200. High local preference. The path with the highest local preference value is preferred. Local preference is used to advertise to IBGP neighbor about how to leave their autonomous system. The local preference is sent only to IBGP neighbors. Since it is advertised, it is transitive but not to every autonomous system like origin type. This origin goes to all autonomous system, you see, informs all autonomous system, but that is not the way local preference works. Local preference is sent to IBGP neighbors only within the AS. Local preference attribute is also well known but discretionary. May be configured, may not be configured, but it is well known. If you don't configure, the path selection will be based on some other attribute. If you configure like this, with one router 200, another router with 150, all the routers in this autonomous system will compare whether to go via this exit or this exit, and they will decide to go via A because A's local preference is higher. Yeah. So that's about local preference. Next is multi-exit discriminator attribute. See, we learned in the beginning BGP is an application layer protocol. So these attributes that we use to select the path explains why it is application layer protocol. Within the autonomous system, one attribute is used. Between the autonomous systems, if you are doing dual homing, what is this called? Dual homing. This router is connected to two upstream that belong to same autonomous system, not different autonomous. If it is different autonomous system, we will call it as multi-homing. Two different WAN connection. Here it is two same WAN connection. Why same? Because it is connected to same autonomous system on the top, but this may be having less bandwidth, let's say 10 meg. This may have 100 meg. Though we have two WAN connections, we are having connections with same autonomous system. Because this ISP, this ISP, when he spoke to you, this is you. When they spoke business agreement with you, they said, hey sir, we'll give you 100 meg, but also take one backup link for 10 meg. Just for safety. In case if this link goes bad for some reason, sir, anything may happen in this world. Corona came, no? So anything may happen in this world. So take one extra link. What is that, sir? Just 10 meg. Additionally, you are going to pay this small amount. So that if this goes bad, for time being, the traffic will go via this way till this is recovered. So you agree for that? Okay, fine. Let's go for that. And you took two connections. We call it as dual homing. Whenever you have dual homing, you see you have policy now. What policy? Because I have 100 meg here, I want all the traffic to come this way to reach this inside network. All traffic should come via B because I have more bandwidth via B. So what we do is we set MED. MED lowest is preferred. The default MED is 0. The default is 0. Even if you leave it 0, it is good. The other one is 200. Always this is lower, no? Lower is preferred. The packet that is here in router D, it will see this network 172.16 via two-way, via B as well as via C. But D will go this way because MED is lower via B. This MED value is also advertised to C. So it is not only advertised between eBGP neighbor, it is also advertised inside the iBGP neighbor, so that if packet comes to this router will say, hey, no, mine is MED too much. I'll send you to B and B will take you to A. Let's read. The path with the lowest MED is most desirable. MED is used to advertise to eBGP neighbor how to exit their autonomous system to reach network owned by this autonomous system. this autonomous system owns this network. MAD is used to advertise eBGP neighbors how to exit to their. So A is saying how you can exit to come to my network. So when I go to A and say B neighbor 150, C neighbor 200, this gets configured here. So I configured here, but impact is here. MAD is used to advertise the eBGP neighbor. A is advertising to the eBGP neighbor like this. Neighbors, how to exit their autonomous system. That's what happened here. Because it is printed here, don't think we are configuring here. No. We configure on A. A will tell B and C how you should exit your autonomous system in order to come to my autonomous system. MAD attribute is an optional and non-transitive. Next attribute is wait. Wait is Cisco proprietary one. Not Cisco proprietary, Cisco's idea. But this attribute is not new to the world. Even though the wait is Cisco's idea, same equal to wait, every vendor has got some attribute. Same meaning but different name. For example, Huawei will call it as preference value. Preference value. What is wait? Path with the highest wait value is preferred. You see, wait is same like local preference, but the difference is wait is local to the router. See, in A, I have configured wait more to this neighbor and wait less to this neighbor. Highest is preferred. So A will prefer to go via B rather than going via C. So what is the difference between this and local preference? Local preference is for all the routers to go via B, whereas wait is for this router only. This router here may go via this way. Wait is local to the router. Now, what is the difference between this and MED? MED is also having same topology, no? See, doing, doing. The difference between this and that is I configure here to say how the packet should leave. Which one is wait? Whereas MED, I configure 150 here to tell this autonomous system how to come inside, not A going outside, how the packet should come inside from the top. That's why this MED and wait is coming as next topic. I configure 150 here, I configure 200 here, so that this top autonomous system will know how I should reach A. I'll reach via the path whose MED is lowest. Whereas here it is opposite. Opposite means literally opposite. You configure here, highest is preferred, and it is for outgoing, not for incoming. The path with the highest weight are preferred. Weights are not sent to any neighbor, local to this router only. This is what called as weight attribute. The last slide for this today's class. BGP, as we spoke earlier, will not select a path using bandwidth or any other metric like you see in RIP and OSPF. It uses only attributes. The attributes are designed in such a way that even if you have multiple paths, BGP will never do load balancing. It will pick one path according to the policy by eliminating all other paths. It will do iteration until it finds that one best path. So definitely there will be one path more best than any other. That one path it can choose through the iteration until the single best path is left. The iteration will be done against the attribute. Such an attribute is what BGP has got. You see, the BGP's forwarding table usually has got multiple paths from which to choose for each network. Even though you have multiple paths, in the forwarding table you will have multiple paths, but not in the routing table. BGP is not designed to perform load balancing. Paths are chosen based on policies, because of policies. Paths are not because of bandwidth. BGP selection process eliminates any multiple paths through the iteration until single best path is left. The best path is submitted to the routing table's manager processor and evaluated against the method of protocol. So this is again next thing. If BGP also gives a route and OSPF also gives a route, same network route, OSPF will be preferred because OSPF administrative distance is 110. IBGP's administrative distance is 200. If it is EBGP, EBGP will be preferred over over OSPF because EBGP is 20. Okay, that is administrative distance. Routing table will take care of it. Anyway, from the forwarding table, not all paths are going to be used. Only one is chosen. Will not do load balancing. Only one by eliminating all the paths. And only the best path is given to the routing table manager, but manager will again decide whether to put this or any other route with better administrative distance. The route from the source with the lower administrative distance will be always preferred. If you have EBGP, then it is 20, that is the lowest among all other routing protocol. Right, we'll talk about this list of attributes in the next class. So in this class we have seen majority of the tunable attributes which we'll be tuning in the lab: weight, AS path, origin, code, MED, next hop. All these attributes we have spoken here, and different types of different classifications like well-known, optional, mandatory, discretionary, transitive, non-transitive, partial. Kindly ask me questions if you have. Question time.